Hello, it's Eric here. And then, first of all, I'm so sorry about the hiatus that I took over the last couple of weeks, and because I was busy looking at the other projects. And like for example, one particular project that I'm looking at is I'm trying to create a new series of videos on finance. Yeah. And then, in particular, I want to look at some of the really dirty tricks that the people use in finance. Yeah, so I'm gathering some material in for that the new series of videos coming up in the future. But in the meantime, we have to wrap up this series of videos on logic. Yeah, and then so last time we were talking about Russell's paradox, and then so we were saying that Russell's paradox is one of those gate crashes, that if you accept this paradox, then the whole of the foundation of the mathematics is going to come crashing down. Yeah. So then, people are not going to allow that to happen. So they have come up with many solutions, and then one of the solutions is the axiom of choice. Yeah. And then we already gave a few examples last time on what it means to have the axiom of choice. Yeah. And then I think last time we had a video on the case where we have different sets, yeah, A1, A2, A3, and each set is a set of some natural numbers, and we say that if you can form a choice function, by selectively taking elements from each set of natural numbers, then you don't need the axiom of choice, yeah. And then, but there are some situations where it's not possible to form a separate set by using a workable choice function, yeah. In that case, you need to invoke the axiom of choice in order to prevent the Russell's paradox from happening, yeah. So here, let me give you a couple more examples on whether or not you need to invoke the axiom of choice, yeah. So the first example is the example 2, yeah. So here, let's say we have many sets, yeah. So each set is actually a pair of shoes, yeah. So B1 is a pair of shoes, B2 is a different pair of shoes, yeah, and B3 is again another different pair of shoes. And then remember, a pair of shoes has a left shoe and then a right shoe, yeah. And they are not the same, Left shoe is definitely not the right shoe because you cannot put the left shoe onto your right foot, And so therefore, we have many pairs of shoes. And then so now we form a choice function. Let's say the choice function is for each pair of shoes, I'm going to select the left shoe, yeah. So that means from the B1 pair of shoes, I take the left shoe. From the B2 different pair of shoes, I take the left shoe again. And B3, I take the left shoe. So that means that I have a collection of all the left shoes, from all these pairs of the shoes, yeah. And so therefore, in this particular case, the choice function works, yeah, because like I said, the left shoe is distinct, from the right shoe in any pair of shoes, yeah. So definitely, this choice function works, yeah. You can form a set of all the left shoes taken from all these pairs of shoes, yeah. So if the choice function works, then you don't need the axiom of choice, and then the Russell's paradox can be avoided, yeah. But then there are situations where the choice function doesn't work, yeah. So let's say, for example, instead of pairs of shoes, we have pairs of socks, yeah. So C1 is a pair of socks, and then so imagine a pair of socks has two socks, with the left sock and the right sock, yeah. But the funny thing is, for a pair of socks, there's no distinction between the left sock and the right sock, And you can always put the left sock onto your right foot, yeah, or put the right sock onto your left foot, yeah. No problem, yeah, because the left sock and the right sock basically are indistinguishable, yeah. So here, let's say for example, I have many pairs of socks, yeah. We have C1, the first pair of socks. C1, second pair of socks is C2. Now remember, these are different pairs of socks, So C3 is again a different pair of socks, yeah. And also now I'm going to have a choice function which is similar to example 2, yeah. So the choice function is I'm going to take the left sock from all these pairs of socks, yeah. So for C1, I'm going to take the left sock, and then for C2, I'm going to take the left sock. For C3, I take the left sock again, yeah. And I'll say, okay, I'm going to make a collection of all the left socks, from all these pairs of socks. Now, unfortunately, in this case, it doesn't work, because this choice function is actually not well defined. Because, like I said, a pair of socks has two socks, yeah, the left sock and the right sock, but they are interchangeable, And so therefore, yeah, you may say that for C1 I take the left sock, but how do I know whether the sock that I'm taking is actually the left sock or the right sock? Yeah, it can be either, you know. And so therefore, the choice function doesn't work in this case. And so therefore, if the choice function doesn't work, then you have to invoke the axiom of choice in order to prevent the Russell's paradox from happening. Yeah. And so, like I said, you know, this is a really deep topic. Yeah, so very, very deep waters in the topic of logic. Yeah, if you're interested, then it's up to you. Yeah, you can do further research on it. And but we have to move on to the next paradox. Yeah, the next paradox I'm going to select the Banach-Tarski paradox. Yeah, it's a wonderful example of you know, how you can you know, manipulate your imagination. Yeah, so I'll see you in the next video. Bye.